Now let's just move on further and talk about the another concept which is related with the chapter, which is nothing but called as the factorization of the polynomial. So in this particular topic, we will start the topic with the factor theorem, and it is really an important and a necessary topic in order to find the factors of the polynomial. So let's just learn about what is the factor theorem. So factor theorem says that if Px is a polynomial of the degree n which is greater than is equal to 1 and a is any real number, then two conditions exist over here. The very first is x minus a is a factor of the polynomial p of x if p of a is nothing but is equal to 0, and the second part says that p of a is equal to 0 if x minus a is a factor of p of x. So this is nothing but a factor theorem which says that if px is any polynomial of the degree which is greater than is equal to 1 and if a is any real number, then these two conditions do exist, which says the very first condition says that if p of a is equal to 0, then x minus a should be a factor of p of x, and the second condition is if x minus a is a factor of p of x, then p of a should be equal to 0, or we can say p of a is equal to 0 only if x minus a is nothing but a factor of p of x. So let us suppose I am proving the factor theorem with the help of the remainder theorem. So let's just prove both of these parts with the help of the remainder theorem. So first of all, let us suppose I am proving it. So I am writing the solution, or we can say we are proving it. So let us suppose we are writing the solution or the proof of this particular theorem as, first of all, we know that by the remainder theorem, we do know that if we have a polynomial p of x, then we can write p of x as nothing but x minus of a q of x plus r of x. We can represent the polynomial p of x in this particular form, where p of x is equal to x minus of a into q of x plus r of x, where x minus a exists as a divisor, p of x is a dividend, q of x is a quotient, and r of x is nothing but a remainder. So let us suppose we are talking about the solution or the proof of the very first part. So from the very first part it says x minus a is a factor of p of x if p of a is nothing but is equal to 0. So it says that if p of a is equal to 0, what is the meaning of this p of a? This p of a actually is equal to the remainder r of x, because we know that from the remainder theorem, if we have x minus a as a divisor of the dividend p of x type, then the remainder should always be of the form p of a. It means that r of x is nothing but is equal to p of a. So in place of r of x, what we can write? We can write it as p of x, which is equal to x minus of a q of x plus of p of a. We can write it in this particular formation where p of a is definitely the remainder by the remainder theorem. So it says that if p of a is equal to 0. Now let's just substitute p of a as 0 in this particular equation. So let us suppose I'm calling this equation as equation number 2. So it says if p of a is equal to 0. So I'm substituting p of a as 0. So it will be p of x, which is equal to x minus of a q of x plus p of a is 0. So anything whatever is adding with the number 0 is again or will repeat the number again. So p of x is nothing at the end we have as x minus of a into q of x. So from this particular equation, we can say clearly that x minus a is definitely a factor of the p of x, because p of x can be written as x minus of a and q of x. So x minus a is a factor of p of x and q of x is nothing but a factor of p of x. So the very first part is clear with the help of the remainder theorem, that if we have p of a or the remainder is nothing but is equal to 0, then x minus minus a is definitely a factor of p of x. So let's just talk about the second part. Again, with the help of the remainder theorem, what we can say, so I'm using this equation number 2 again. With the help of the remainder theorem, we can say that p of x can be written as x minus of a. Let us suppose I'm changing the quotient. I'm not writing q of x, I'm writing g of x. So let us suppose x minus of a into g of x plus p of a. Let us suppose it is of this formation where gx can be any particular polynomial. So p of x can be written as x minus of a, g of x plus p of a. So it says that if x minus a is a factor of p of x, then p of a should be is equal to 0. So it says that if x minus a is a factor of this polynomial, so let us suppose we are talking about this only. If x minus a is a factor, it means that x is equal to a is nothing but the zeros of this particular polynomial, and if it is a zero of this particular polynomial, then it will definitely satisfies the whole condition. It means that, let us suppose I am substituting x is equal to a, I am substituting x is equal to a as a 0 in this particular polynomial. So what we can obtain from this? Let us suppose I'm talking about if x minus a is nothing but a factor of p of x, then it will definitely implies that if it is a factor of this, then it will definitely implies that we can substitute x is equal to a over here. And moreover, the remainder should be is equal to 0. It means that p of a should be is equal to 0. So let's just talk about the second part. The second part says that p of a is equal to 0 if x minus a is a factor of the p of x. So it means that we can write p of x as nothing but x minus of a g of x, where g of x can be any polynomial. So g of x is any polynomial over here. So as per the given condition, it says if x minus a is a factor of p of x, it means that we can write p of x as x minus of a into g of x formation. So it says that p of a should be is equal to 0. So let us suppose we are substituting x is equal to a in this particular equation. So if we are substituting x is equal to a in it, the value we will get as p of a is nothing but is equal to a minus of a g of x, or g of a minus a is nothing but definitely is equal to 0. So p of a is nothing but is equal to 0. So this is the result that we are getting, that if any x minus a is a factor of the polynomial p of x, then p of a is definitely is equal to 0. So this is all about the proof of the two parts of the factor theorem. So always remember the factor theorem or the two parts of the factor theorem in order to factorize the polynomial. So this is a really very important theorem for the topic factorization of the polynomials.